Hi, this is Paul Edwards with Denmark Company. Today I'm going to introduce the Universal Chlorinator, and I will be talking about the fundamentals of this unit. I will try to explain the safety steps that should be taken, and this will be a multiple part series, a lot like other products that Denmark carries. I like to create a number of video continuing educations just to try to create clarity with the different elements that are involved with all our equipment. As you are familiar with, Denmark Company has dosematic pumps, we've got foamers, we've got all kinds of items that are either chemical feed or chemical application. And this happens to be one of them, the Universal Chlorinator. The whole idea of the Universal Chlorinator is to take our palletized calcium hypochlorite and meter it in such a way so that the chemistry is added to water that is intended for an antimicrobial intervention. As you know, we are governed by 7120.1, which is the safe, suitable ingredients. If you need a current copy of that, let me know and I'll get it for you. So the 7120.1, the safe, suitable ingredients, is a document by USDA that tells you what concentration that you can utilize of a particular chemistry. In this case, calcium hypochlorite on carcasses are approved to 0 to 50 parts per million. So this chlorinator would be used to manage a 50 part per million stream at the high end, or a 5 part per million, somewhere in there at the low end. And this would be applied directly to carcasses. Now, if you have the case of a primal, then you can go on and spray directly on primals at 0 to 20 parts per million, free available chlorine. That is a property of calcium hypochlorite. The word calcium is a key word in this, because chlorine is generally a solution-based chemistry. So chlorine can be created in a number of ways. Chlorine is created by bleach. Bleach is a manufacturer of chlorine. Sodium hypochlorite is the common name for that. And then this tablet, a tablet particle, would be the calcium hypochlorite would be a solid. And so what I'm doing for our benefit is I'm grabbing a tablet and I'm putting it to the screen so that you can take a look at it. This is what the tablet looks like, okay? The very small tablet too, as you can tell, okay? I'm going to bring it closer to the lens, and you see as I bring it closer to the lens, you see the size of it. Pretty interesting. It's less than the size of a dime. Okay, less than the size of a dime, and in diameter. So in thickness it's thicker than a dime, but in diameter, or circumference, whichever you want to go by, it is smaller. Now, the important thing to realize from a safety aspect of chlorine, as you saw there, I had my gloves on when I grabbed that. The other thing too that you want to have is safety glasses. You want to protect your eyes. You want to protect your hands. And then we do sell the chlorine badges so that you can protect your exposure to airborne chlorine. So keep in mind that when you purchase a kit from Denmark, it comes with the chlorine badges. But if you do not have latex gloves, or you do not have goggles, or safety glasses, let us know, because we carry those in stock and we'd be more happy to provide that. This glove here, little sales pitch, is an 8 mil glove. It's very, very thick. It's one of the thickest nitrile gloves, chemical resistant gloves out there on the market, and we carry it, so we're excited about that. Okay, well, back to the chlorinator I want to talk to you about. First of all, every chlorinator, including this one, has an inlet and an outlet. So I'm going to start off with the inlet side. This would be the inlet side over here. You see this side here? This here would be where the inlet side is. And generally, what you would do is you would take a water hose like that, and you would connect it directly up on this side. And a lot of these components you have yourself on site. So we sell these additional components as options to your startup. So, you know, a lot of people already have ball valves. They don't want to buy a ball valve from us. There's a nipple right here, and then you have your water hose connection here. So a lot of people don't want to buy this from us, but if you don't have it, it's an option to buy it from our test kit. So we want to encourage you to do that. One of the things that I noticed when I was working with this chlorinator is that it really didn't have a good design on mounts. So now what we do is when we ship this chlorinator out, it comes with mounting brackets, and then it also comes with a backboard. So it's going to have a backboard, it's going to have the brackets, and it's going to have, all of those are charged options, but that's how it ships, so that you get that. And then you have your chlorinator. And that is not optional. You get that when you purchase this package. Okay, so there's a lot of stuff that I could go over with the chlorinator. I want to try to make it as basic as it possible as I can while you're learning. But let's start off with the basics. So you have an inlet here, okay? The water comes inlet here, and then it goes into this chamber-like device, and then it comes out here. So this here is your outlet side of your chlorinator. See that? See that outlet side there? And what I'm going to do is I'm going to make some adjustments here in a second so that we could see that. But here's your outlet side, and as you can tell right here, I've got a filter strainer. I got more, it's actually more like a strainer. We've got a strainer here. I'll talk a little bit more about that strainer in a little bit. And then I have, at the very end here, I have my outlet. This is my water outlet, okay? And that outlet right now, the way I have it designed is it's feeding directly into a 5-gallon bucket. So that outlet would feed directly into a 5-gallon bucket. It could be feed into a pump up sprayer, and then on later videos I'll show you some other neat little things that you can do with this design. But right now we're keeping it basic, and we're just talking about the chlorinator, and we're talking about filling up buckets. Okay, so that's where our focus is going to be. So you might be wondering, where does that pellet go? You know, where is that pellet going to go in this design? So what I'm going to do is I'm going to answer that question for you in just a second, but I am going to make some adjustments to my camera so that we can get a better view of what I'm talking about. So just hold for a moment. I'm back. I've repositioned the camcorder here so that I could go on and show you some things about this. Well, first of all, anytime you're going to open this container, there's instructions here with an arrow on it, and it says on this arrow, to open, turn that direction. To close, turn that direction, okay? So what I'm going to do is I'm going to take this locking key here, this opening key or closing key, whatever you want to call it, you know, my little crankshaft or whatever you want to call it. But I'm going to use that. Comes with your item that you order. And I'm going to go on and see what I'm going to do here is I'm going to hold this and I'm going to turn it. And I want to make sure when I open it that I got real good secure handle on it. Okay, now it was a little struggle, and the reason why it was a little struggle is because I probably over tightened it when I tightened it up. So how do you know when it's tightened enough? You don't have any leaking. How do you know you over tightened it? well, you have a heck of a time getting it over, okay, open, okay? So that's your indicator there. I'm going to pull the cap off. And one of the things, a caution here that I want to give you right now is I want you to, when you open this, keep in mind that you may or may not have a gas formation in here, okay? And I'm going to explain that as we go on the training. I want you to know that there are some real issues that we face, and I want to talk about those real issues, okay? Well, the first thing is activation, and gas formation. So you want to be real careful of that, and I'm going to show you some tricks of the trade that help prevent that from that. So why would you open this container up? Okay, well, the reason why you would open this container up is to fill it. So if you're going to fill it with chemical, what you would do is you would sit there and you would take the chemical and pour it in there. And I'm going to demonstrate that here for you. So your product comes to you in a container like this. It has Flaco in it, and it says caution there. And then here you have your instructions on this side, and here you have some first aid items, and so this is really important that you understand your first aid steps. And then we have our chemical 1-800 number on there for any kind of emergency assistance. And so anyway, we recommend that you read these instructions before you actually start messing with this system. You want to know what you're dealing with, okay? So the first thing is you're familiar with the chemistry, you've looked over the MSDS, you know what are the things you're going to protect yourself against. You do have gloves on, and then you have your goggles on. So you have your chemical that's in here, your tablets are in here. Do not leave this container cap off, okay? When you open it, close it. Whatever your purpose for opening it is, do it and then close it. Same thing with this. Whatever your purpose for opening it is, open it and then close it right away. So my purpose here is to add chemical to this, okay? So how do I add chemical to it? I take this and dump it in here, okay? Did you hear that one that didn't fall in, that just kind of fell out? Okay, well, they're going to have that, okay? Generally speaking, two more. Generally speaking is you want to go on and add this on there, and then you want to close it up. Now, this opening up this unit here is something that you only do when you wanna go on and fill that up. Any adjustments to this device, any adjustments like cleaning this out, whatever, if you intend to clean this out, okay, this is a very important point that I'm going to make, okay? If you're intending to clean the contents of this out, what you want to do is you want to totally take it off the wall. Okay, guys? It's on a bracket here, right? This is your bracket. This is your holding in place bracket. Okay? If you intend to take the contents out of here, you need to take it off this bracket. And what I'm going to do for your benefit is I'm going to go on and demonstrate what that technically means, okay? So, if I want to take this off, the first thing I'm going to do is I'm going to disconnect this right here, okay? So how do I do that? Just grab pliers and I turn this. But probably the better thing to do is take the hose off first, right? Take the hose off so that you don't have a hose that keeps going around in circles and tightening up and becoming a nuisance for your effort to take this apart. So you're going to go on and take this off here, right? You're going to take off this ball valve, right? And so you take your ball valve off. Okay, this is going to be a really good video explaining a lot of stuff for you, right? So you take that off there, take your ball valve off, and then you come over here on this side over here, right? And you've got this assembly here that you need to take off too, right? But let me show you some neat little things. Okay, first of all, you see these little these little nuts here. Let me go on in, or actually, they're bolts. See those little bolts? Or screws. Some people call them screws. I call them bolts. Anyway, these right here are to hold this in place so it doesn't lean or doesn't fall over. This is very top heavy. So I put these in place so that it wouldn't fall over, okay? So that's what the purpose of those bolts are, is to keep it from falling over, okay? So if I want to take those bolts off, all I have to do is grab my tools, come over here, and obviously my water's turned off because I just disconnected the hose. So that's another thing that you need to remember, is that you've got to turn off your water before you do that, okay? And when you get ready to take the bolts off, you got to go in the right direction and unscrew it. So there, I've just unscrewed that. Same thing here. A lot of times when I have it is hand tight, but if I don't, use your automatic, what is it called? Automatic wireless screwdriver, automatic driver. Anybody about like me that we don't know the actual mechanical name of some of these items, so we just kind of fake it and call it something different, like automatic wireless screwdriver or drill screwdriver, or we just call it all these different things. And then the manufacturers are going, what's wrong with these people? They don't even know what it's called. Well, it's because you guys invented it, and we're trying to come up with our own name for it because we're inventors too. So see how that just comes right off, guys? See how it just slipped off? Did I do that right? Did I have enough backspace on it? So basically what happens is you've got a skinnier spot. You see, and you slide it in that skinny spot on your, and then what you do is you go on and feed it into the middle of this bracket, and then what you do is you screw this in place. So you see how I did that? So if you intend to take the contents out of this, okay, out of this, before you open this up. Now I have this hand tightened, okay? I'm gonna do this, okay? I've got to take it off the bracket in order to do that. Okay, now what I do is when I tighten this up like I'm doing here, that applies pressure directly on that fitting. So by doing that, I apply pressure on that fitting, and it keeps it from slipping. And the reason why it keeps it from slipping, and I have it on both sides, guys. You're probably thinking, why? I mean, you could, if you did it just on one side, you know, that's what would be all it needs. It's not going to come off if you got it on one side, right? And I agree with you, but I'm one of those guys that I like to overdo it just so that I don't have to worry about somebody getting hurt. So I put these screws on both sides, you know, and that's the way I'm going to ship it to you guys. So just get used to it, you know. I mean, yeah, I just think that it's neat to have safety first, and that's what I'm trying to do. So I've got these bolts or screws on both sides, and so what I've just done is I'm starting to reassemble this. And you see how I have Teflon tape on there? You can put some more Teflon tape on it. I like Teflon tape. I don't mind putting an excessive amount of Teflon tape on something, and the reason why I don't mind is it keeps it from leaking. So I mean, to me, Teflon tape is great, okay? Guys, I want to be honest with you. There's still a lot I need to learn about this Chlorinator. It's a new product that I just picked it up for our lineup. I really like it. It's gotten like 5 patents on it. You know, I've talked to the original inventor of it. Seems to be a really nice guy with some really great ideas. And I'll tell you what, I'm one of those that if somebody else has a very good idea, I'm proud to make it part of my product line. And that's how I feel about this product, is that it's a good product, it makes sense, it works. Well, I tell you what, when it works, it's really important. And that's the reason why we're carrying it, okay? So now I want to talk about the fact that I filled this up. This generally comes to your plant assembled for your intended purpose, okay? And what I mean by that is that I know that this water is going to go through, it's going to go through this unit, it's going to draw the appropriate part per million of chemical, and then it's going to come down a hose into a bucket. So I know it's application, I know that it's going to work. So when I got this unit, I made some changes to it. So I'm going to talk about the changes here in just a second. These are not changes to the manufacturer's original design. Don't get me wrong. What I did was I took the manufacturer's original design, his instructions, and I made changes to this unit. I'll explain that in a second. I'm going to put you on hold for just a moment and reposition the camera. Okay, what I want to bring to your attention is a dial setting on the side of this chlorinator. See this dial setting here? It turned, it's the literature on here says off at that point and max at that point. Okay? So I'm going to do that again. Off here, that's off, and this is max. Okay? Inside of that, there's a tube, and the tube looks like I'm going to show you this one right here, okay? These units have a tube. They come with these two items, okay? I naturally order them with both these, okay? You see, this one right here looks just like that, okay? Do you see that? Now, here's what the difference is. That right there, that's installed, that unit there has a hole here, okay? And that hole on this dial attachment, okay, or dial option, that hole allows it, by its engineering, that when you turn it, I'm trying to get my hand position where you can look at it. When I turn it, the hole opens and closes larger. So technically speaking, this dial is by the size of the hole. Here is fully open hole. This is fully closed hole. That's how it meters the chemical in here with this design. Okay, now let me talk a little bit about that design here, what we're talking about here. Okay, this is some of the areas that is still gray to me, and I'm still working out the facts on it, how it applies to our customers. But I can tell you that when I ship this to you right now, 9 times out of 10, it's going to have this unit in it, this attachment, this option that has the hole in there. We're going to use it as that design, okay? So I've tested it extensively, and at 0, okay, or close to 0, generally speaking, it's about 2 to 3 parts per million. So there's enough carryover and enough seepage in this system that I can assure you that you're not quite at off. There's always going to be some sort of a residual amount of chlorine coming through, but it's very small amount and very difficult to detect at off. But I'm just telling you now, it's not completely off because I haven't seen it completely off, okay? But the reason I say that it's not completely off is there's a lot of residual coming through this system. And I'm describing residual as carryover from this point to the end point. Okay? So, even though you put it on off, it could be a while before it's completely no chemical on this side. Okay? It's going to be a while. Okay? So I don't want you to think of that off as being off right away. Think of it as off over a period of time, and that period of time has to include the flushing of all possible residual chemistry that's caught in this chamber. Okay, guys? Now, the important thing there is that you know that is the way it operates. Now, there is an alternative method that this system works, and I will tell you briefly about it. but I'm not going to go into it a lot because you're not going to be using it often, okay? And that is this device here. As you see this device, okay, this device is in the middle of this chamber, okay? And as you can see, I'm trying to get my camera, but you see that hole there? See that hole there? Look at this. Look at that. See that hole? It changes there. You see the hole changes there? There's an instruction manual that tells you what the purposes of each of those holes are. In the other design where you're using this device, here that has no hole, when you use this device that has no hole, this is the device that's controlling concentration. This center piece here, okay? But when you're using this device here, this dial setting that has the hole in it, not this one which has no hole in it, then this is set to no holes visible. You see where there's no holes visible there? See how there's none? Okay, that's the difference, okay, folks? Now, please, give me time to work out the rationalization of that. Okay, I'm still learning about the rationalization of that. So give me time. Right now, when you get this unit, and for the time being, for a while, you'll be using it at no holes in this center tube. Okay, no holes. And you're using this with a hole in it. Okay? Did I make my point there? I hope I did. Okay? So I want you to know that that dial setting, I have tested it with about 3/4 full of the tablets, the calcium hypochlorite pellets. And I found that to be here at about 2 to 3 parts per million. And here, fully open, to be 60 parts per million, maybe. Okay, maybe 60 parts per million at a continuous flow rate of about 3 gallons per minute going through here. So we're talking about 3 gallons coming in, 3 gallons going out. I'm going to talk to you a little bit about pressure differential, because this system here runs on a 20 psi pressure differential. Let me explain that to you, because I know that some people may not know a lot about pressure differential, and so I want to talk about it and explain it in layman's terms. And then if you want to get with the manufacturer and ask more questions, that's fine. Or if you want to go and Google pressure differential, you'll be able to get some information there as well. But I'm going to create a what if scenario. Let's say, what if the pressure coming in on this side, which is your inlet side, was 30 psi, and it goes through this unit, what would be the pressure on that side? On the outlet side. Okay? Well, I'm going to answer that question for you. If there's no head pressure over here, like you're filling a bucket, it's easy. I needed to get some water because I didn't bring water to drink, and while I was in the middle of conversation, I feel like I probably need some. But when the water goes in here, I just turn it on and stick my mouth right here, right? That would do it. When the water goes in at 30 psi and it comes out and there's no head pressure, then that means it's just going directly into the bucket. That is a pressure drop of probably 30 psi. There's probably not any pressure on this side able to measure, because it's going directly into a bucket and there's no resistance. So you come in here at 30 psi and the resistance is this chamber, but the moment you come out on this side, okay, there's no real resistance, okay, because it's going into a bucket, right? Starting to get the idea of pressure differential? Pressure differential is a measurement between inlet pressure and outlet pressure, and the outlet pressure gains when there's all of this opposite or opposing pressure on the outlet side. So opposite and opposing pressure is, bam, buckets. If it goes directly into a bucket, very less opposite and opposing pressure. But how about if I start to run this a distance? How about if I have a pipe on this side, on the outlet side, a pipe, and it goes 30 feet? Now we're starting to build pressure, okay? But what if that pipe leads into a bucket? Well, then you still will have a pressure drop, probably of over 20 psi, because you're going into a bucket. But what if that pipe that's 30 feet out is going into a spray cabinet? And the spray cabinet only has 2 nozzles. And those 2 nozzles are very small orifice nozzles. Guess what? Now my pressure has increased considerably, and that pressure increase considerably is going to affect the performance of this unit. Because this unit requires a 20 psi pressure drop in order to function correctly. So that means that on the inlet pressure, if you're at 30, then you cannot have more than an outlet pressure of 20 psi. So if I have an inlet pressure of 30 and an outlet pressure of 25, 30 minus 25 is a 5 psi differential pressure. Not good. What if I have a 10 psi outlet? 30 minus 10 is 20 psi. I have the minimal needed for this unit to work correctly. Okay, are you starting to get the idea of differential pressures? So folks, if you're going to go to a spray cabinet with this unit, I would recommend that you put in a gauge, a pressure gauge on the inlet side and a pressure gauge on the outlet side, and make sure that you have that pressure differential. Because if you don't, it's not going to work ideally. Okay, I'm not going to say it's not going to work at all, but it won't work ideally. Okay, now I'm going to get towards the end of this systems explanation, and I'm going to put the camera, reposition it, and go over some more information, and then we'll be done. So I'm sure you're glad about that. Hold a second. Okay, now I'm on the outlet side of the chamber. Okay, folks? So I am on the outlet side of the chlorinating unit, universal chlorinator. I'm on the outlet side, and as you can see, it's going in to a screening device or a filtering device for suspended solids, and then after it goes through the screening, it comes out and then it goes into the bucket. Now you might be wondering, why do I have that? Why do I have that little screening device there? And did you see that little ball valve there? Here, let me go and adjust this so you can see the ball valve, okay? Adjust that. See the ball valve? I'm adjusting that there. And see that ball valve? That ball valve is to purge the contents of that screen. So the ball valve is your purge valve to purge the contents of this. And then you have your hose that's going to go directly in the bucket. You see that hose that's going to go directly in the bucket? Okay, that is, after the hose is where you're testing for your chlorine, your free available chlorine, right? After the strainer, okay? Now you might be wondering, why the strainer? Okay, calcium is a solid. It's the binding agent of the chlorine molecule, and so ideally you would want the tablet to dissolve completely, but sometimes with this design, this unit design, it doesn't have complete dissolving of that tablet. So that strainer there is to catch the suspended particulates of a specific diameter. Okay, if I can take a little bit more and take a little bit more time to explain the screener here for you, for your benefit, is that screener is designed to take particulates of a certain micron size and separate it from the water. Okay, so when you have an undissolved particulate that comes out of your outlet side here, the undissolved particulate, it goes into the strainer captures it, And then on the outlet side, you have your flow into your bucket. Now, there are particulates that are getting through this screen, okay? But they are very fine particulates that are getting through that screen. So what is my option? Well, my option is to go to a filter that is designed for more fine media, fine solids. And so we're like for example, if you wanted to strain flour, okay, you could strain it with this screen, but some of those fine particulates of flour are going to get through it. So what you do is you go to a greater filter capability. So if you go to a 10 micron filter, it's going to remove all visible solids, because anything on along a scale, and what they call atomic size scale, when you look at something in an atomic size scale, it goes from ionic, that means it's dissolved in solution, and most particulates like calcium and magnesium, the things that you find in water, and the reason why the water looks so clear is because it's in an ionic state, okay? It's a dissolved solid in an ionic state. It's completely dissolved. It's completely in the solution. You can filter the calcium hypochlorite to that degree, but you have to have a filter design to remove any and all suspended solids. So 10 micron will do that. The only thing is that, when you go to a 10 micron filter, it's not going to affect at all your chlorine. Your chlorine is still going to be the same, and it's still going to get through, because chlorine is a oxidizing charge that exists in water that's going to do its job. It's an oxidizer. It's a charge, electrical charge in the water that's going to react with the bacteria or an organic load, and it's going to lose that charge. That's what chlorine is. It's electrical charge in the water. It's not going to be changed by those suspended solids, okay? Because they originated from those suspended solids. So it's not going to be affected by that suspended solids. So by going to a more finer, a 10 micron cartridge, like they have what's called paper filters, pleated paper filters that will go down to 10 micron. They have also some woven filters that will go down. So there's a lot of options, but you're wanting to be around 10 micron if you don't want to have any presence of a visible dissolved solids in your stream. That's what you would use. But if the presence of a visible dissolved solid is not a problem for you, and all you're interested in removing is the solids that are precipitating, solids that are big enough to filter out with the screen and will fall to the bottom, precipitate to the bottom, and then you can come back into this ball valve here, down here in the bottom, and purge it. If those are the solids that you're interested in removing, that's what's ideal about this filter. If you don't want anything visible coming out of this hose, then you want a 10 micron filter to take that out, because 10 micron filter is going to remove all visible solids, okay? And we would have to find a canister that would fit a 10 micron filter. It wouldn't be this canister, it would be another one, okay? So anyway, I'm pretty much done, folks. You guys, there is a video that talks about test kits for chlorine, calcium hypochlorite, and how to use them. So I'm not going to do that. I'm not going to belabor that. I'm just going to say, watch that video on using your test kits regarding calcium hypochlorite. But this right here, this unit here is what you use for filling up buckets, filling up, if you've got a solution that you're going to add to a primal dip system, or if you have a solution that you're going to put in a pump-up sprayer for direct application to carcasses and direct application to primals. This is it right here. There is one other approval, 0 to 10 and parts per million. The 0 to 10 parts per million is processed waters that are applied for meat. And I am working with key people that are part of my team to determine whether that approval of 0 to 10 for processed waters, what does that mean for our customer base? So I'm still defining that for y'all, so I don't really want to talk about that just yet. I just want to tell you there is one other approval, but I'm still learning more of what a processed water is compared to a water that sees a primal and compared to a water that sees a carcass. There's a defining characteristic, and I'm trying to get an idea of what that means to our customers. So give me a chance to work out that question there. If you have any questions for me, please call me up at 817-822-5767 or email me at danmarco1@msn.com. We really appreciate your interest. This is a continuing education opportunity for Danmark Company and its customers. There is no warranty expressed or implied. All we're trying to do is help you here with general information, but we encourage you to take every possible resource, including the manufacturers of the chemistry and the manufacturers of the equipment, to find out all the things that you need to know. Of course, Danmark Company will provide you with your certificate of analysis, your technical but supporting documentation, and all the things that are very critical and important to you, and we do enjoy doing that for you. So thank you very much, and I appreciate your time.